So today we are going to discuss chapter number 19 of physics second year, that is atomic spectra. So the first topic is, what is atomic spectra? What is atomic spectra? For example, if we have a substance, this is a substance. If we have any substance and if we heat it, what will happen? Its atom will absorb energy. So this is substance in which atoms are present. This is nucleus and this is electronic shells in which electrons are present. So if we heat it, what will happen? Electrons will get energy and will excite it. So it will jump to the higher energy states. So the electron stays there for a short duration, like 10 raised to the power minus 8 seconds. In excited state, the electron waits for how much time? 10 raised to the power minus 8 seconds. And after 10 raised to the power minus 8 seconds, it falls back to its lower energy states. So what happens? It absorbs energy and moves from its state to excited states. Now after 10 raised to the power minus 8 seconds, it again fall into its original state with emitting a radiation called photon. So after falling back to its shell, it emits a radiation called photon. So when it is supposed to a discrete packet of light energy, what is photon? Photon is discrete packet or light of energy. Light packet, packet of light. Packet of light. So it it emits a proton, which is packet of light. Now the frequency of emitted radiation or photon is equal to the frequency with which the electron bounce back and forth. For example, if this is two shells, now the electrons goes up and down. Again it goes up and down, and again absorb energy and again came to its original shell. So 1, 2, 3, three types of photon, 3 photons will be emitted, and the energy of photon will be to it how much speed it comes forth and back, or back and forth to higher energy state. So if it takes high time, so it will form wave like this. And if it takes short time, so it will form wave like this. So this is about the frequency. Now in solid and liquids, if this is solids and if we have liquid, so solid and liquids have fake electron. Their electrons are fake one above the other or one with each other. So they don't have electrons to get into the excited state. So it doesn't form any state. Now for gas or one atom, if we give it energy, it will absorb energy and falling back to its original shell, it will radiate what? Packet of energy. So the spectrum that will obtain from it will be line spectrum. For example, if this electron, we get energy to this electron, many electrons will get energy, many electrons will absorb energy, and after 10 raised to the power minus 8 seconds, these all electrons will fall and with specific photon will be emitted. And if we provide a surface, so that each line will form a line. So the spectrum of such atom is called atomic spectrum, and this is line spectrum. Each atom has its own line spectrum. So when someone claims that he has discovered a new atom, so check it. How to check it? We will bring the atom and we will check its line spectrum. If its line spectrum matches with other elements, so his claim is wrong. It is no new element, but it is same. So each atom has its own line spectrum. So each element, this is important, that each atom has specific line spectrum. Now About the hydrogen, the spectrum of hydrogen. Now spectrum of hydrogen. When hydrogen gas is placed in discharge tube, for example, if this is discharge tube and we place it what? And we place inside hydrogen. So a discharge cause it means of high voltage, and if we apply it high voltage, the hydrogen gas will ionize and it will becomes luminous and gives up a light, and the color of light will be, it will produce light, and the color of light will be bluish red light. The bluish red light is for hydrogen. So this is important for ETA, that hydrogen is placed in discharge tube. So what color it will be produced? It will produce bluish red light. So if we pass this, if this is luminous light produced, and if the same line we pass it by prism, for example, so it will give us a line spectrum between visible region, infrared region and ultraviolet region. In which region? Infrared region, visible region and ultraviolet region, and the region in the spectrum will be line spectrum. So the first of all, the Balmer was scientist in 1885, discovered and pioneered its wavelength, and by formula he states formula that 1 over lambda is equal to R 1 over 2 square minus 1 divided by NQ square. So where R is Rydberg constant and its value unit is 1.097 multiplied 10 raised to power 7 per meter. Both sides have the unit of lambda will be the unit of R. So 1 over lambda is 1 over meter. So 1 over meter is the unit of R. So this is the R value 1.097 multiplied 10 raised to power minus 7. Now Balmer predicted that other series of line might exist outside the visible. This was in visible for second shell of the second electron of the second shell. So which would obey the equation given as, now the rest it was only for second shell, and he said for other 1 over lambda n will be equal to R 1 over p square minus 1 over n square, where p is, if this is an atom, an electron excited from this state to this, so the first shell or present shell is p and the second shell is called n shell, where n is equal to p plus 1, and here we can say n is equal to p plus 1. If we add one shell to it p, it will become n. So present shell and next shell. Now for the spectrum of hydrogen atom it was only for second shell. Now F for electron, for hydrogen atom, if this is the nucleus of hydrogen atom, and we have shell 1, we have shell 2, we have shell 3, we have shell number 4, and we have shell number 5, and we have shell number 6, and so on, and each shell have its electron. So if we heat it, what? If we heat it, electron would gain energy, and after falling base to a shell it will give us a photon of which there will be a specific wavelength. So there are different series. The series is based on which electron will jump and fall to its original position. So the first one is Lyman series, Lyman, Balmer, Paschen, bracket, Papan. This is the series Lyman, Balmer, Paschen, bracket, Papan. So the first shell take the energy, and it goes to the second shell, and it falls to its original shell. So the photon will be emitted. So to find the wavelength of that, we will use the Lyman series formula, that 1 was lambda 1 is equal to R. Here p is equal to 1 square minus 1 over n square, where n may be 2, 3, 4 greater than 1, 2, 3, 4 and so on. It may gain energy to reach to the second shield, or it may gain reach to the fourth, third, fourth, and so on, and it will fall again from that after 10 raised to power minus 8 second. The next, it can also occur for second electron. The second electron can also get. So it depends on the electron field to which number shell. So if it is number second shell, so Balmer. If electron part to third shell, that is past shell. If it is 4 bracket and power 5, it is fifth one. The same is on this value changes. So 1 over 2 square in this case, and past shell it is 1 over 3 square, and bracket it is 1 by 4, and this is 4 square. In general, we can say that 1 over lambda is equal to Rydberg constant and 1 over p square minus 1 over n square, where n will be equal to p plus 1 or p plus 2 or p plus 3 and so on. Its value will be always greater than p. So the next is Bohr model of hydrogen atom. This was about the spectrum of hydrogen atom. So they didn't show here the which one is Lyman, which one is Balmer, and which one is Bastian. So must remember it that Lyman series occurs in ultraviolet region. The Balmer series occur in visible series or visible region. So that's why Balmer discovered it and he used prism. The next was phase change, bracket, and pipon. These occurs in infrared. So starting from ultraviolet passing to visible, and it then goes to infrared. So we can also say that if this is infrared region, this is visible region, and this is ultraviolet. So here the Lymans occur, Bastian, bracket, Lyman, Balmer, Bastian, bracket, Pfeffer. So for ETA and any other test, they ask us that Lyman lies where. So Lyman line is ultraviolet, Balmer lies in visible, Bastian line in near infrared, Balmer mid infrared, and Pfeffer fair infrared. This is fair infrared, this is mid infrared, this is near infrared. Or simply, if there is no near, mid or forward, you will select infrared. So near, mid and fair, must remember this. The next is Bohr model of class 19th. This is just a piece of cake. According to Bohr model, the basic postulate of Bohr model of hydrogen are as follow. Number 1, the electron moves in a circular orbit in the nucleus, that influences the Coulomb force of attraction. So as the electron moves in circle, its mv square, that is centripetal force, that is provided by Coulomb force, that is the charge, the force between the electron and the nucleus, and the Coulomb force is k e square divided by r square. So first postulate was the Fc, that is centripetal force, will be equal to the Coulombic force. So mv square by r is equal to k e square by r square. The next is only those orbitals are present for which angular momentum is the product of h divided by 2p L, that is angular momentum, or rp or angular momentum. He stated that only those shells orbits are possible for which angular momentum is equal to product of h divided by 2 pi. So the first shell to second shell, third shell, and so on. So he said that the momentum will be h divided by 2 pi, or 1h divided by 2 pi, or 2h divided by 2 pi. We can also write this is h divided by pi. Done. The next is 3h divided by 2 pi. We can also write 4h divided by 2 pi. So 2 cancel with 2h divided by pi. The next is 5h divided by 2 pi, and so on. It means that the momentum will be nh divided by 2 pi. So if they give us an MCQ that which one of the angular momentum is not possible, and the option is h divided by 2 pi or h divided by pi. So this is looking like irregular, but this is right because we derived from here. And if they give us 3h divided by 2 pi, and search that if there is any other case, that if they give us h divided by 3 pi. So this is not possible. So this is not angular momentum, or this shield is not possible. So the angular momentum of the shield must be the product of n, number of product of h divided by 2 pi. The n may be 1, 2, 3, 4 and so on. This was the third postulate. The next was simple, that electron, if its electron is revolving in its state, so it does not emit or absorb energy in resting state, in state. So for fixed state, if electron is there circulating or rotating with speed, so it will not emit or absorb energy. Now in fourth postulate, if the electron jump from this shield to another shield, the first shield energy is E n. This is P present and n is next. So if electron jump from P to n, and again after 10 raised to power minus 8 second it falls towards P, so he will emit energy. So the change in energy will be occur to according to E n minus E P. The lower shield have low energy and the high shield have high energy. So this is high energy E H and this is E L, low energy. So when the electron passes from high energy to low energy, it will emit the extra energy. So the energy of the photon will be energy of changing. So change energy is E n minus E P. Now to find the radius of orbit of Bohr model. So you must remember it directly formula, or we can also find it. So to find the radius, must follow this step. So we know that MVR, that is angular momentum, is equal to that comes from LR. So L is PR. So angular momentum, this is angular momentum is equal to MVR is equal to NH divided by 2 pi. Angular momentum will be the product of h divided by 2 pi. So from here we can write that V is equal to NH 2 pi and M R will be here come from top to bottom on left side. The next is, for electron to stay in circular orbit, the centripetal force is provided by Columbic force. Next we know that centripetal force mv square by r is equal to ke square divided by r square. Here centripetal force is equal to Columbic force. And we also know that k is equal to 1 over 4 pi epsilon naught. Now putting the value of V in this equation. Here we have the velocity, but we don't know the velocity of electron at which is moving. So we will replace this velocity. By velocity will be replaced by V is equal to this. Where here is square, so we will take square on this. So V square is equal to n square, h square, 4 pi square, m square and r square. So putting here n V square, what will we get? M r ke square divided by r square. So putting here V square, so putting this V square here, we will get n square, h square, 4 pi square, m square and r square. So we get this equation. Now we know that r square into r is equal to r cube. This will cancel. Now taking this r cube to this side, we will get r cube. So r square will be cancelled with r cube. So we will get r. Now m will be cancelled with the power of m. Again we will get n square, h square on this side and 4 pi square, and we will get ke square into division. So we will get ke square into division and we will get r. So r is equal to k n square h square k 4 pi e square. Now we know that k is equal to 1 over 4 pi epsilon naught. So putting here 1 over 4 pi epsilon naught, the 4 pi epsilon naught will move upward. So we will get 4 pi epsilon naught n square h square is equal to r, and division we will get the same value 4 pi square e square. So 4 pi cancel with 4 pi and we will get R is equal to N square H square N square H square epsilon naught divided by E square. So we can use this equation or this equation, but the suitable equation is this one, that R is equal to N square H square K 4 pi square E square. So this is the R. Now we know that N is the number of shield 1, 2, 3. So this H is constant, 4 is constant, K is 9 multiplied 10 to the power 9, that is constant, 4 is constant, pi is constant, E is electron, that is constant. So putting all these values, we will get its value is equal to N square into 0.53 multiplied 10 to the power minus 10 meter. Writing at another page, we will get that R is equal to N square 0.53 multiplied by 0.53 multiplied 10 raised to power minus 10 meter. So this is the formula for radius. Now to point for radius number 1, if R is equal to 1, N will be is equal to 1. So 1 square to the power 1 is equal to 1. 1 multiplied by that is equal to 0.53 multiplied 10 raised to power minus 10 meter. So this is the radius of first shell. So if this is the nucleus, not if this is the nucleus, so this is the first shell, and the radius of this shell is 0.53 multiplied 10 to the power minus 10 meter, or 10 to the power minus 10 meter means 0.53 angstrom. This N will be changed. For 2, we will get 2 square into 0.53 angstrom. So 2 to the power 4, 4 5s are 22.0 angstrom. So it will become, it was 0.5, so this will be become 1, so this will be become 2, so this will be like this. So this will is 0 point or 2 point something. So this is the radius of second, this was the radius of first. Now to find the radius of third, we will just put it 3 square multiplied by 0.5, 3 angstrom is equal to 3 3s are 9, 9 5s are 45, 4.5 angstrom. So we will get 4, this was 2, so for 4 it will come here, and next for R4 we will get 16, and 16 5s are 80, so we will get 8 point something angstrom. So this was for second, this was for 3, this was 4 angstrom, and for next which is 4 angstrom. So we can see that this distance between R1 and R2 and R2 and R3 are increases, because the first change was from nucleus, it is 0.5 meter high. From nucleus it was 0.5 meter, 0.5 angstrom. The next, it is the distance is, the difference is 1.5 angstrom. For next it is 2 angstrom. For next it is 4 angstrom. So we can say that as the number of shell increases, the distance between them also increases. So generally if we can draw, so we will draw the first shell near, the second little far, the third one is more far, the fourth one is 4, and so on. So this going forward, so we can say that Rn is equal to R1, the second is 4 times of, this is 4 R1. So next is 4 R1, and next is 3 to the power 9, 9 R1, and next number shell is present in 4 square and 0.3 is R1, 16 R1, and the next is 25 R1, and next is 1 2 3 4 5 6 36 R1, and so on. So this is the shell. Now what this was about the relation between the radius. Now what in case of the energy, what will happen to the energy? So energy relation, that is quantized. Now let us compute the energy of hydrogen system for a given N. The energy consists of kinetic energy and electrostatic potential energy. So this is nucleus, this is shell. So as the electron have from a distance up from the nucleus, so it have electrostatic potential energy. As the electron is moving with the velocity with some direction, so it has also some kinetic energy. So the total energy is the sum of kinetic energy plus potential energy. Now we know that kinetic energy is equal to half mv square. Again, as there is velocity, so we will replace velocity by something. So from velocity we know that mvr, that is angular momentum, is equal to nh divided by 2 pi. So v square is equal to n square h square 4 pi square m square r square. So this is the relation for velocity square. So putting this velocity square here, we will get that. I put this is, we can put this. So again we will get n. So we are going to follow kinetic energy from another velocity. We also know that where was kinetic velocity. So the next was here the Columbic force is equal to electrostatic force. Columbic force is equal to Fc, where Fc is equal to mv square by r. It is simple, ke square by r square. So r cancel with r, v square is equal to ke square by m. So we will put this equation. This is little easy. So putting here half is equal to m, v square we will put ke square by m, where m cancel with well. So we will get half ke square, because for equation for potential energy we will get it is in k. So I will use this equation, not instead of this, because the potential energy there will be k. So we can add and we can add then. So the kinetic energy is equal to half k square, and there was one single r. So we will put here r. The next is the potential energy. So the electrostatic potential energy. So we know that for electrostatic potential energy, so in every time use work as an electrostatic potential energy. So we know that W is equal to Ft. So W is equal to here W is equal to Fd, or in this case this is radius, so we will get Fr. Now we know that F is equal to Columbic force. F is equal to ke squared by r square into r. So r cancel with r, we will get ke square by r. So electrostatic potential will be always negative, because it is the energy when we apply from getting electron from this state to the another state. So it will always equal to 90. So the next is minus potential plus potential energy. So plus potential energy, where plus potential energy, here the potential energy is equal to minus ke square divided by r. So this is the potential energy, and this is kinetic energy. Now the next is E is equal to half ke square by r minus ke square by r. Now taking ke square by r constant, we will get 1 over 2 minus 1. So 1 over 2 minus 1, what will we get from 1 over 2 minus 1? We will get minus 1 over 2. So ke square by r into minus 1 over 2 is equal to minus 1 over 2 ke square by r. So this is the energy equation, where if we put the r value, where r was what? Where r was n square h square 4 pi square k m e square, or 4 pi square k m e square. Putting here this, we will get that that energy is equal to minus half ke square by r. By r we will get n square h square divided by 4 pi square k m e square. So this is the relation. Anything to cancel? N square, nothing is k. We can multiply k square. K we can multiply it by 1 over 4 pi. This is k, and this is also K. So we will get K square, is there are both two K's. So we will get, this is the energy equation. Now here if we see everything is constant except N. K is fixed value, E is fixed value, 4 is pi, K, M, E square, H square, all are fixed value. So putting the values and calculating them, this is equal to minus, it will get some value E naught divided by N square. So putting that E naught, that is minus 13.6 EV, electron volt, 13.6 electron volt divided by N square. Or in case of joule, it is 2.17 multiplied 10 raised to power minus 18 joule, but this is not important. You can convert electron volt into joule. So this was the relation. Now this was a theory. Just you can also remember the end equation. Now this is a nucleus. This is a nucleus. Now this is the energy of E1. This is the energy of E2. This is the energy of E3. And this is the energy of E4 and so on. So we know that En is equal to what? Minus E naught divided by N square. E naught is equal to minus 13.6 divided by N square electron volt. So this is for another shell. This is number 1 shell, 2 shell, 3 shell, 4, 5, 6 and so on. Now for shell number 1, E1 is equal to minus 13.6 divided by 1 square is equal to minus 13.6. So this energy is minus 13.6. The next is for E2. E2 is equal to minus 13.6 divided by 2 square. So 2 2s are 4, 4 3s are 12. So we will get 3 point something or 3.4 electron volt. The next is E3. This is minus 3.4. The next is E3. E3 is equal to 13.6 divided by 3 square. 3 3s are 9. So 9 1s are 9. 9 1s are 9. We will get 4 40. 9 4s are 36. So it will be minus 4 electron volt something. E4 minus 13.6 divided by 16. 4 square. So 16. So it is less than 16. So we will get 136. So this is 16 10s are 160. 16 8s are, so we will get minus 0.8 electron volt. So this is minus 1.4, this is minus 0.8 and so on up to some time we will get at a value 0 or near to 0. So why did I solve this value? Why did I solve for E1, E2, E3 and E4? So if they give you that an electron was heated at gain energy and was moved to electron shell number 4 and it pass again to the E1. So find the energy for that. So we can say that this was the energy and electron fall to this shell. So the delta E will be the energy of photon. So energy is minus 1.4 minus 13.6. So this is the answer. Yeah, minus 1.4 plus 13.6 or 13.6 minus 1.4 is equal to 14.6 or 14. So this is the 13.6, 12.6. So the 12 electron volt is the answer. Now to point the per Lyman series, what is the energy per Lyman series? E2 minus E1, because per Lyman series the electron falls to first shell. So per Lyman series minus 3.4 minus 13.6 is equal to something. This is per Lyman, for formal, per Paschen from packet paper. So if we find this shell, minus 3.4 minus 1.6 minus 3.4 minus 1.36, this is delta E, which is E2 minus E1. Now if we find this, this is E2 minus E3 minus E2. So the more high you go, the energy increases. The value is decreasing, but its negative value. So as the value is decreasing, this is the value increasing actually. So as far as you go to high shell, the energy is increasing. So this was about the energy. Now we can also say that energy of a shell is equal to what? E1, that is minus 13.6, or the second shell energy is E2 divided by 4. The next shell energy is equal to E1 divided by 4, E1 divided by 9, or it is equal to E1 divided by, there will be minus. So E1 divided by 16 and so on minus E1 divided by 25 and so on. So this was about the energy. Now the next is hydrogen emission spectrum. What? Hydrogen emission spectrum. For hydrogen emission spectrum, for hydrogen, we have hydrogen gas, there is many energy levels. So if the electrons get excited by gaining energy, and after 10 raised to power minus 8 second, if it repels to its shell, a photon will be emitted of its energy E. So as photon is emitted by energy E, so it must have some wavelength. As it is energy, so it must have some wavelength. Now to find how the wavelength of the hydrogen emission spectrum. So we know that as electron gains energy, the energy of the photon is the change of the energy of En minus Ep. What is En? This is Ep present, or this is N next shell. So to gain energy and to fall energy. So as the electron reach to the N, it again fall into P. So the energy of N is greater than the energy of P. N is high energy level. So the energy of N is high and energy of P is low. Now we also know that En is equal to minus E naught divided by N square, and for P the shell number is P, so we will get E naught divided by P square. So putting these two here we will get, and we also know that E is equal to HF. E is equal to HF. This energy HF is the photon energy will be equal to E naught. En, this is minus E naught divided by N square minus EPS minus E naught divided by P square. So this was. Now further solving, we can say that taking E naught, we can also write that E naught divided by N square minus into minus is equal to plus, we will get E naught divided by P square, or we can also write just interchanging the place, we will get E naught divided by P square minus E naught divided by N square. Taking E naught constant, we will get 1 over P square minus 1 over N square, and this will be HF. So we know that V is equal to F lambda or C is equal to F lambda. So here F is equal to C divided by lambda. So putting H is equal to F is equal to C by lambda, we will get C by lambda E naught divided by 1 over P square minus 1 over N square. Also taking these two on the left side, so it will comes downward, so we will get 1 over lambda is equal to E naught divided by HC into 1 over P square minus 1 over N square, where E is constant, H is constant, C is constant. So solving these, we will get 1.097 multiplied 10 raised to the power 7 per meter. So this is equal to value that of Rydberg constant. So we can also write that 1 over lambda is equal to R naught or RH. So that is equal to 1 over P square minus 1 over N square. So this is the per hydrogen spectrum wavelength. So this equation is similar to that of, this is same as that of Balmer, but Balmer in this case he used, instead of P he used 2 N. Bohr theory, Bohr give us that this equation. So both are same. So this is the equation that we can use for higher energy state, where P is not 2. We can use it for P is equal to 1, P is equal to 2, P is equal to 3, P is equal to 4, and so on. So this is the wavelength equation to find the hydrogen spectrum emission wavelength. Now for energy diagram, what is energy diagram? We already discussed it. So if this is the nucleus, this is the A1 shell, of which energy is minus 13.6. This is another shell, of which another is minus 13.6 divided by 2, or 2 square divided by we will get is 4 point something or 3.40. The next is next shell energy, of which energy is equal to minus 13.6 divided by 3 square, of which energy is minus 1.51, and so on. We will get the energy. So its value is minus 13.6, 3.0, 1.1. The next is 0.85, and next is minus 0.54. So this next is minus 0.38. So don't remember energy level diagram, just remember this one value 13.6. Now next one is for 2 divided by 2 square, this is the energy formula, and E2 is equal to En divided by 2 square, for E3 is equal to 13.6 divided by 3 square, and this is E4, that is minus 13.6 divided by 4 square minus 13.6 divided by 5 square and so on. So if the electron get excited by Lyman series, this is the Lyman series in which electron falls to the first shell. So if the electrons falls from second shell to the first shell, what will be the energy of photon emitted? So this is the difference of E2 minus E1. 2 energy is 3. This is the nucleus particles, suppose. So this is E2 and this is E1. So this is E1, this is E2. Now delta E is equal to E2 minus E1. So E2 is equal to 3.40 minus 13.6. We will get some value. Now in case of this, we will minus 0.85 minus 13.6 and so on. So for Lyman series, these all values are possible. So for Balmer series, what will happen? If this is n is equal to 2, this is 1, 3, 4, 5. The next is in Balmer series, the electron falls to second shell, so it may come from third shell, it may come from fourth shell, it may come from 5 shell, 6 shell, and so on. In past time, the electrons fall to the third from fourth, or it may come from 5 to third, or it may come from 6 to third. All are possible. So this is the energy level. So it is possible. It may come from 3 to 1. Possible. Nothing matter. But energy will be changes. E3 minus E1. E3 minus E1 in that case. If it falls from 4 to 1, so in that case, if the electrons falls from E4 to E1, so in that case, E is equal to delta E is equal to E4 minus E1. De Broglie wave in the hydrogen atom. So Bohr told us that angular momentum will be the product of NH divided by 2 pi. Now De Broglie say that if this is the circumference of this is the shell, so the shell must have in form of waves, it must form some waves. So because both atom have electric particle as well as wave nature, so electron will move in such a wave. Now for more than decade Bohr publication, no one was able to explain why angular momentum of electron is restricted to these discrete units. Nobody knows. But for the first time De Broglie told us. How? De Broglie says that this pattern has 3 full wavelengths. In this case it is 1, 2, 3, 4, 5 wavelength. So we can also draw this is one part of the wave, and this is another third and so on. So they say that we can form it, this is in the form of wave. So electron will move in, instead of circular path the electron will move in this like wave form. Is excitation and ionization potential. Excitation and ionization potential. So the Bohr model as well as the current quantum mechanical model of atom predicts that the total energy of electron is quantized. Energy is quantized, that is equal to E naught divided by n square, where E naught is equal to minus 13.6 electron volt divided by n square, where n is equal to 1, 2, 3 and so on. The state in one is called ground state. the first n is equal to 1 is called ground state, and for rest of state where n is equal to 2, 3, 4 and so on, these states are called excited states. Now when energy is supplied to an atom, then electron in an atom reach out to excited state. The atom in excited state cannot stay for a long time, and the electron in excited state soon return to lower energy level by emitted photon. This is same as the previous, that electron from nucleus when from one shell, if we heat it, it gains energy, it gains to the excited state. There it stays for 10⁻⁻8 seconds, and then it again fall emitting radiation. Now the energy required to move electron from this state to this need energy, because this is low energy. Again, if this is E1 and this is E2, we find that as we move upward the energy increases. So electron absorb energy. So which one energy this is needed? This is absorb energy. Now the energy required to remove an electron from a ground state to excited state is called excitation energy. Excitation is the energy needed for excitation is excitation energy. Doesn't need any definition. Excitation energy is the energy that is required for excitation. What is excitation energy? When electron absorb and it jump from ground state to the excited states.
Energy में increase की क्या?
additional की एनर्जी लगी पदी की सिवाय नमुंगा देले एनर्जी और कुछ दे बरत होगी सोने एनर्जी वाला पकार है दक एनर्जी तो सो एक्साइटेड स्टेट जितनी एनर्जी चाहिए उतनी इसको कहते हैं एक्साइटेड स्टेट
एनर्जी में इंक्रीज की हो काइनेटिक एनर्जी बड़ी इंक्रीज की
एनर्जी रिमेन कांस्टेंट kan तो पिता का लाइफ लाई कड़ी तो आप गिरुस तरे दा आप मुंगेले हो कने वेलोसिटी रुस तो सोना पर बरजी वेलोसिटी डिक्रीज की दे रेडियस तरे तक लगता है आओ अगर वेलोसिटी ऑफ द रेडियस तक लगता है velocity is inversely proportional to radius square हो जमा ख्याल है. The next is that we say how to find this E. So this is a little tricky, not as much as, for example, a first and second excitation energy of hydrogen is calculated. First excitation energy mean that from the ground state where n is equal to 1, electron energy required to move electron to the first excited state is called first excitation energy. Now here the energy is minus E naught, and the next level the energy is equal to minus E naught divided by 2 square. So we know that you already know that now, this is previous knowledge. So the energy absorbed is the change in the energy. How much? This energy is low and that is high. So the energy we will give is this from minus this from this. So we know that
minus 3.4
minus E naught divided by 2 square. This is high energy, so we will minus the first low energy, that is minus E naught divided by 1 square. So we will get minus E naught divided by 2 square plus E naught divided by 1. So we will get 1 over 4. So solving this we will get 3 by 4 into 13.6, that is E naught value. So we will get 10.2 electron volt. Now this was all about calculation, but how this is the first excitation energy, the energy required to get electron from ground state to the first excited state, matlab the next first level. So this calculation, to skip this calculation in easy way, to skip this, what we do, we will see that the first energy is 13.6 x and the next is minus 3.4 something. So if the change in energy is delta E is equal to minus
E2 minus E1,
E2 minus E1 minus, this is the energy, minus E2 minus E1, that is minus 3.4 minus 13.6. So we will get 13.2 easy. Done. This was excitation energy. Now another term is excitation potential. So what is the difference between excitation potential? So this was excitation energy is the energy. So in case of potential, excitation potential is that voltage that must be applied to electron at its ground state to get amount of energy equal to the excitation energy. Same potential if we apply that cause same excitation by the excitation energy. For example, the first excitation energy was 10 electron volt, 10.2. So the first excitation potential will be 13.2, but we will replace electron volt by voltage. So this is first excitation potential. Now for second, you can also find the second, third and so on.
The second जी मालूम है तब असंग मालूम है E3 में
For second excitation potential, we will use E3 minus E1. Either you can find by this way, E3 minus E1, where E naught is equal to, we will get this equation, but you will just get E3. So we will get minus E naught divided by 3 square plus E naught divided by 1. So solving this, we will get that, or you can also solve that E naught minus E naught divided by 3 square. So we will get, to solve this, we will get some values. Ionization energy is same as the minimum energy that is numerically equal to the ground state of the atom. For example, the ionization energy per hydrogen is 13.6 V. Now let me clear it. If this is atom, again I need your attention, latent attention may be needed. So if this is electron, we get enough energy to move it from the ground state to the first excited state. So this will be called first excitation energy. Again, if the electron get enough energy to get to the second excited state, so we will call it second excitation energy. So we know that as we go higher, the energy increases. So but at some stages outside the electron, if the electron goes outside, outside mean where energy is 0. Outside the atom there is no energy, so the energy is 0. If electrons move outside the atom, then it will never come back. So how much the energy is required to remove an electron? So the minimum energy required to remove an electron from atom is called ionization energy. So in this case, ionization energy is ionization energy of outside minus energy of inside ground state, where this is E naught divided by 1 square. So as this energy is 0, we will get minus E naught minus into minus E naught by 1. So minus into minus is equal to E naught. So ionization energy is the just numerically equal to the ground energy state of the hydrogen, that is 13.6 eV. So 13.6 eV is the ionization energy of hydrogen atom. So energy in the first shell is minus 13.6, while the ionization energy is the 13.6. If they give that for some atoms we have the E1 is 10 electron volt. So what is the ionization energy? So we can say that ionization energy is opposite of it. So if this is minus 10 eV, then it will be 10 eV. Now also if they give that second excitation potential, if they give that second excitation potential is, how much? If this is minus 20 eV, excitation potential always positive, so this is 20 eV. Or if they say that energy of second E is or E2 is, if they say that energy in second state is 20 minus 20 eV, find what? Find the ionization energy. So what is the relation between E2 and IE? So if this is E2, we can find E1, where E1 is equal to, where this is the relation, E2 is equal to, we know that if E is the energy of initial, for E1 this is E1 by 1 square, and for E2 this is E2 by 2 square, E1 by 2 square, and for next this is E by 3 square. So in this case we can write this ratio, where E naught or E1 is equal to, for E2 this is equal to E1 divided by n square. So part 2 this is 2. So we know that second shell energy is 4 times that of E1. This is the inner relation. Again on second page I would like to draw your attention that we know that E naught En is equal to minus E naught divided by n square. Power 1a E1 is equal to E naught divided minus E naught divided by 1. So for E2 we know that minus E naught divided by 2 square is E divided by, or we can write minus E naught divided by 4. So minus E naught is the energy of one shell, so we can write that minus E1 divided by 4. So for E2 we means that it is minus E1 divided by 4. It is minus E1 divided by 4. So E2 energy is 4 times that of, there is a little mistake. So E2 is equal to minus E1 divided by 2 square. So minus E naught divided by 4. So this is the energy of one shell. So we can also write it E1. So E2 is equal to E1 divided by 4. So this is the energy relation, but this is minus side. So as the minus, the value will be decreases, but the minus is negative. So as the minus value increases, it means that actually the value are increasing. So this is E2. This is the relation between E1 and E2. So if they give us the energy, we can find the ionization energy. This is the relation between E2 and E1. Inertial transition and characteristic X rays. This is simple letter. If this is the nucleus, this is K shell and this is L shell and this is M shell, K, L, M. So the electrons may come from L shell, it may come from L shell to K, from M shell to K, from N shell, and so on. So if electrons come from L shell to K, energy will be removed and this X rays will be removed, and this rays is called K alpha. So if next shell, if it comes from second shell, then we will call it K beta, and if it is from third shell, we will call it K gamma. Done. Now if from third shell or from M shell energy electron pass to L shell, we will call it L alpha. If from next shell, we will call it L beta, and from next shell we will call it L gamma. So this is alpha, beta, gamma. So the next is M alpha. If from K, L, M, N, if electrons from N to M, we will call it M alpha. If it comes from O to M, we will call it M beta, and so on. So these alpha, beta, gamma are the three types of X rays. Now if this L, this is called K alpha, this is K beta and K gamma, and they occur in X rays. So these are the three types of X rays. These are the three types of X rays. Alpha, K beta, K gamma. These are the types of X rays. And other something else in the physics first year or no, this is the point. Here they says that X rays may be hard rays or X rays. So this is not types of X rays. X rays may be soft or hard, but the types of X rays are what? The types of X rays are K alpha, K beta, and gamma. So in ETEA 2018 there was MCQs that the types of X rays are 2 or 3. So the hard rays and soft rays are not types, but types of X rays are K alpha, K beta, and gamma. Alpha, beta, and gamma are the types of X ray. So option 3 is correct. Many students did the mistake.
Alpha, beta, gamma is the K?
Alpha, beta, gamma. K alpha, K beta, K gamma is the types of X rays, not soft and hard. The next is the last topic, then we will discuss the next chapter, or you will leave it as just a theory. that what is continuous X-rays. So if this is incoming electron and this is the nucleus, so the attraction of the nucleus accelerate the charges, and this accelerate charges emits a radiation, and this acceleration is called braking radiation, and this radiation is called X-rays, continuous X-rays. Why? If this electron is attracted by this, so it will give radiate emission. After some time, as it come follow, it will again radiate, so and so on, it will radiate electron, and it will be depleted lower energy electron, so it will lose its energy, and again it will give us X-rays. So this type of X-rays production is called continuous X-rays. So that is no need that let's consider an extreme example in which electron loses all its energy in single collision. So if this is the nucleus, this is the shell, this is the nucleus and this is the shell. In continuous X-ray, this is the other way. If electron is moving and it is attracted by the positive nucleus, so this positive, the force of attraction accelerate these electrons, and according to classical theory of electromagnetism, an accelerated charges emits radiation. This charge is being accelerated due to positive nucleus, and according to electromagnetic theory, an accelerated charge produces photon. So this charge will give us radiate what? Photons. So suppose a special case in which the electron hits the nucleus and it loses all its energy, or in the special case in which initial energy of electron. What is the initial energy of electron? That is electron volt, where E is the charge and V is the voltage which is supplied to the electron in discharge tube. So if this electron is moving with initial energy of EV and it is completely transferred into the energy of photon, so it is converted into energy of photon. So if this a special case in which EV is totally converted into the maximum energy possible. So EV, if maximum energy is possible, we know that E is equal to H, F will be maximum. As E is maximum, so frequency will be maximum, or we can say that H is equal to C divided by lambda. As frequency will be maximum, so lambda will be minimum. So the photon radiated will be with high energy, it will be a high frequency, but its will be minimum wavelength. So this minimum wavelength is equal to what? H, which is constant, C constant, E constant, and V is voltage that depends. So lambda minimum, this is the equation for lambda minimum, which depends upon the voltage. So if they give us to calculate the minimum wavelength produced when electrons are accelerated to potential difference of how much? For example, 10 or 1000, 10,000 or 1 lakh volt. So how to find the minimum wavelength? We know that H is equal to constant, that is 6.6 multiplied 10 raised to power minus 24. The next is C, that is 3 multiplied 10 raised to power 8. E, that is charge, 1.6 multiplied 10 raised to power minus 19. Next is volt, and the voltage is given, that is 10 raised to power 1, 2, 3, 4, 5, 6. 10 raised to power 6. So just solve it and you will get the answer. This was the second way of production of X-rays. The third way, we can also produce X-rays just simple. Next is production of X-rays by another method. So the production of X-rays by another method is simple. Like for example, if we take a filament and we connect it to the current, so as the current is passed, heat will be passed in, maybe electrons will be removed from it. The next is we will apply voltage. What we will apply voltage is in this section. The voltage will be high voltage. We will connect a metal here, so this will be high voltage. Sometime it is about 50,000 volt, 50k volt, or sometime it is 100k volt or 1 lakh times. So this voltage is that much powerful that this positive charge can accelerate electron from this side. That's why we apply the high voltage up to 1 lakh voltage. So the next is the anode is made of solid copper or bar C. So here we will put the metal target. So here we will put what? The metal target. So turning on the button, electron will be removed in first step. In the second step, turning on the voltage button, the positive and negative charges will be appear. So this electron will be attracted by positive charge as the voltage is 1 lakh volt. So the electron will move and start motion with high speed. So as electron is moving toward positive, so they have embedded metal in its mid. So as the electron hits the metal, X-rays is produced. X-rays are produced. So this is another way of X-rays. Now this X-rays is possible to pass through. If we have X-rays, it has the ability to pass through objects. For example, it can pass through human body, but it can't pass from bone. Now there are some rays. If we take an object and we pass rays, some rays can pass touch outside while some rays can pass inside. So there are two. So we can say that rays which can penetrate for a long time, these are called hard X-rays, and those which cannot go any further inside, these are called soft X-rays, which depends on its penetration power. Now its properties of X-rays: it can be reflected, it can be directed, fluorescent may be substance, it has many effect in photographic plates. The next is it is used to find the structure of crystal. It is used in CT scan, also for X-rays, and so on. It was enough for waveform. He said that this circumference will be the product of wavelength. Either it will 1 wave, 2 wave, 3 wave, 3, 4, 5, and so on, not will half of it. And the circumference is equal to 2 pi r. He just draw this circumference in form of this and said that this circumference will be the product of length, and 2 pi r will be is equal to nh, where L will be 1, 2, 3, 4, 5, and 6. Now we already know that this angular momentum is equal to h divided by p, or lambda is equal to h divided by m v. We already know this. So putting lambda value here, we will get that 2 pi r is equal to n. Putting this here, we will get n h divided by m v. Now in next case, rearranging m v into this place, m v with r, and h 2 pi will move to the left side, right side. So nh divided by 2 pi. So this was the result. So first time de Broglie calculated that Bohr was right, and this equation is 100% correct. Now Bohr is correct, but there is limitation. Which one limitation? The Bohr model is just too good for hydrogen or single helium atom ionized, or double ionized lithium atom. When the number of electron increases, the Bohr atoms then fails for it, or multi electron system, the Bohr atom fails for that. So these three you must bear in mind. For these three, the Bohr atom model is 100% correct. Furthermore, the Zeeman effect, Stark effect, which was due to electric field, and Zeeman that was due to magnetic field, the Bohr model didn't explain that correctly. So this was the limitation of Bohr model, that it is useful only for hydrogen plus, and lithium double plus sign. It fails for multi-electron system, and this was short trick for proof of MVR is equal to NH divided by 2 pi. So n per 1, 2, 3.
ये संकड़ा है ये दीप एन पर से ये पूर बोट